Here we shown that linear algebra top 10 prediction questions for the GATE 2026 exam. First, here these are the topics based on the analysis of 2024 and 2025 papers. Let's start with the first question. Let A be the matrix of 3 by 3 with real entries. Let a trace of A is 6 and then determinant of A is 6. Okay. If one of the eigenvalues is 2, what is the other two eigenvalues? The question is very simple. First, let me analyze that what formulas we know based on the material we learned is the sum of the what is given, the trace of A is nothing but a sum of diagonal element. It is nothing but sum of eigenvalues is means 6. So he gave that determinant of A is 6. Okay, it means one of the eigenvalues is 2. It means we 2 into 1 into 3. It is nothing but 6. Then we got, so answer is these, or 2 into 2, 4, 4 to 8. So answer is not there because 8 is occurred. We need must be 8 will be occurred. So 2 into 4, 8. So it is, this is also not the correct answer. Next, 2 5 is 10. So it is also not the correct answer. So answer is will be 1 comma 3 based on the simple trick by knowing the just a single formula. So answer is A. Let we another check that it is correct or not. So here the answer is 1 comma 3. That how I solve this is just applying this formula only. If you apply this formula, but there is a chance to uh, solve some calculation. But if we solve the calculation into multiplication, then it is easy to sort out the answer. So that's why I use the property 2 to solve this problem. Okay, then next question is vector subspaces. Which of the following sets is a subspace of R square? Okay, so given the subspaces is S1, S2, S3. So in the S1, x comma y, the condition is x plus y is equal to 0. Okay. X plus y is equal to 1. This is also okay. X greater than or equal to 0, y greater than. Which of the following sets is a subspace of R square? Based on the analysis, if x plus y is equal to 0, it means there is a chance 1 x is 1, y is minus 1. But there is also a chance 0 plus 0. So it becomes 0. So there is a chance it is a subspace. X is greater than or equal to 0, y is greater than or equal to 0. Okay, there is also a chance to subspace. So the answer is S1 or S3. Here you observe that S1 or S3 is our become the answer. So though S2 is not our correct answer. So I observe that this is not our correct answer, and this is also not our correct answer. So the answer is in between these two. So answer is A or C. So let me check. So answer is A. So it means the S3 has a, why S3 is not 1, we check that. So here x and y greater than or equal to 0. It is a closed run tradition but fails the scalar multiplication for negative scale. Okay, I understand that. If a scale, and for example, if multiply with 1 and minus 1, but it is failed it is becomes it is negative 1. So it means negative scalars it will be failed. So that cases the S1 is the correct answer. Okay, this type of way we need to solve the gate exam paper questions. Next, let u and v be the two non-zero column vectors in R power n. Let A is equal to uv transpose. What is the rank of the matrix? Here you clearly observe that it is in the format of A transpose. It is nothing but orthogonal format. In the orthogonal form, the rank of the matrix is nothing but plus or minus 1, right? So the answer is either C. Depend, maximum answer is not n, right? not 0, right? Actually, I think the answer is these two in between them. Let's check. Okay, the answer is 1. Why I said the answer is 1 is because the the orthogonal matrix, the eigenvalues of the rank of the matrix A is must be 1. Why I said is, let's check that. Here you observe that the matrix is in the outer product of the two vectors, right? So each column of the A vector is scalar multiple for vector. So since all columns are linearly independent, it means that it is independent, it is linearly dependent. It means it is dependent because the one only one linearly independent column rank will be 1. This is how we observe that. First, here this is the matrix we given that. So by solving that scalar multiplication, we observe that all columns are linearly dependent on U, but there is only one. It means U is not equal to 0. Yet this only one linearly independent column is available. So at that situation, we are utilizing that the rank will be 1 because there is a one linearly dependent linearly independent will be available. So that's why the rank will be 1. Next question is, consider a matrix A 1 1 0 1. The singular values of A are calculated as square roots of the eigenvalues of the matrix. Nice. Here we observe that here this is the 2 by 2 matrix. The singular values of the matrix A. It means the singular values is nothing but the eigenvalues of the matrix is it is must be orthogonal matrix. In the below form, the orthogonal matrix condition satisfied only this one. So the answer will be the option C because let us say that it is in the orthogonal format. That's why I am saying based on the we learned before classes. So the answer is not these A, B, D. The answer will be definitely C. I just predicted, but it is correct or not, I don't know. Let's check that. Wow, Josh. Here the answer is because this is the rule we learned from the material. So this is the correct answer. If you want this the complete material, then go through the Surya wave.me web application. Then you got the perfect results and perfect accurate formulas and all among these things will be available in that material. So you need to prepare well for that exam. So next one is, let P be the projection matrix that projects any vector onto a subspace. Which of the following conditions must be P satisfied? So here the question is very simple. It is gives that projection matrix. In the projection matrix, the condition is, so the projection matrix must be follows that idempotent and one is idempotent matrix and another one is wait, p square is equal to p is nothing but idempotent matrix. It is nothing but symmetric matrix. So it follows these two conditions. So that it means the option will be B. So let me check. So here we shown that the answer because the orthogonal projection matrix must follows these idempotent and symmetric conditions. So next thing is, so let me explain that. Next one is, so consider the system of linear equations Ax is equal to B where the m and so it means that if you have infinite solution, for the infinite solutions the answer will be definitely this is the correct answer because we have the certain rule in the tabular form. So this is, I think that will be the correct answer. So let me check that. So question C, the option C. So yeah, right. So here these are the conditional table that is available in the material. Next, if a Q is a real n by n orthogonal matrix, which of the following statement is not necessary true? So it is nothing but n by n orthogonal matrix. In the n by n orthogonal matrix is Q transpose Q is equal to I. So I think this condition will be satisfied, or which of the following, and this condition also will be satisfied because q transpose q inverse is nothing but a transpose a is equal to y. So I think a and d, these two will be satisfied, but let me check which one is correct. So the answer is C. Why? Wait a minute. The Q is a real n by n orthogonal. Which one of the following is not necessary true? Okay. Actually, in the question, he included that not necessary true. It means which one is not suitable that we asking. A is suitable, right? D is also suitable. These are the correct answer. But in the question, based on the given, it is not, he asking not, so it means, so this is not correct answer, so this is also not correct answer. So the answer will be these two. The columns of the q are orthogonal, that means the answers will be these 2 points are there. For the orthogonal matrix, the data of q is, we can't say it because it is true or false, there is not necessarily true. So the determinant of q is equal to 1 is the not necessary true, it means it is the correct answer based on the situation. So you need to understand the question very well at any point, that way we need to solve the points. So here this is the, this way we applied, then we got this points. So this is the wrong, not corrected of our answer. Next, a symmetric matrix A is said to be positive definite if for all non-zero vectors x. Positive definite, it is nothing but, it is positive means the answer will be this all eigenvalues. So the answer is not becomes, because in the table we learned that these two are not suitable, and it will, there is a chance to be, it will be the answer correct, or there is a chance the answer is B or D, not in the AC. So let's check that. So the answer is B. So based on the table, if it is greater than 0, then it is positive definite. It is positive semi-definite means it is greater than or equal to 0. This is the condition we need to solve. Next, a square matrix A is decomposed into A is equal to L into lower triangular matrix and upper triangular matrix. L is yeah, he given that the determinant of A is equal to. So here he said that the determinant of A, the determinant of A means um, the determinant of A means product of diagonal elements. So the answer will be, which product of diagonal elements of L, products of diagonal elements of U, sum of diagonal elements of U. So no, I think the angular matrix which are all diagonals are equal to 1. All diagonal elements equal to L is a lower triangular matrix which all diagonal elements are equal to 1. It means that means I think the answer will be, yeah, I think answer is D. So sorry. The answer is what he given. Answer is B. Why? Delta of A is equal to delta of LU, right? So delta of L into delta of U. Okay. The delta of L is equal to product of diagonal elements. The product of diagonal elements means is here. So delta of A is equal to delta of U. Delta of U is nothing but product of diagonal elements of U. And U is an upper triangle. Data, okay, let apply the determinant on both sides. So data of A is equal to data of L in data of U. Okay. Delta of L is equal to product of diagonal elements. Delta of the L is the lower triangle with all delta of L is equal to 1. Okay. It means delta of A is nothing but delta of U. Okay. So delta of, yeah, the product of diagonal elements becomes U. This is the correct answer. So I mistake this one. Next one is rank nullity theorem. Let A be a 4 by 7 matrix. If the dimension of the column space of A is 3, what is the dimension of the null space? In the rank nullity theorem, the relation is rank plus nullity is equal to n, right? So that is the relation. So here rank of A is 3. What is the dimension space here asking? So in the ABA 4 by 7 matrix, it is nothing but n by m, n into m format. For let we take if n 4 minus 3, it will be 1. The answer will be 1. I think there is a chance to get it is correct or it is wrong, but so it is wrong. Why? Wait, is okay. We know the formula is correct, right? What in what cases we failed? So the failed cases is A is 4 by 7 and n is 7. Why n is 7? It means there is a m by n by m not. Okay, m by n format is available. So it means there is a chance that the n is 7. So in this case, so it means, so actually I take n is as a 4. That's why we got the wrong answer. But we take m by n format, the n is 7, so that we apply the same formula here, then we got answer will be 4. So it means the answer is C. So thank you for this linear algebra topic, and well prepared for the GATE 2026 exam. Bye bye.